Hello there, in this video I will show you how to embed a Python interpreter into a C++ application like you see it on screen here. First I show you how I set up the project in Visual Studio. If you're not interested in this part, you can skip a few minutes. I'm using the CMake template in Visual Studio and set the names appropriately and just start it up. As you can see, I already get a warning in Visual Studio. This is because I used the vcpkg package manager for static linking, and the default is dynamic linking, so I have to change this value in the CMake configuration, save that file, and then we can change the CMake lists files to set up the project. I will now copy and paste some lines from the other screen. First I set the C++ standard to 17. Then I set the output directory to be /bin, and then this big part here is just for setting warning stuff and code analysis in Visual Studio. Then there's another CMake lists file inside the main folder, which is only for the executable. Firstly, I set a new variable called target name, just for convenience, so I don't have to type the word main everywhere in the code. So I can just replace it with the variable name. These lines set the file names for the executable files, and these lines set the warning level for the compiler. That's it, that's the basic setup. Now I'll delete the header file from the CMake template because we don't need it, and now replace the code inside the main CPP file with just a little hello world-like program, just for testing if the CMake configuration works. And it does. Now we have to install a library called pybind11 that's used for the connection between C++ and Python. I'm using vcpkg to install the library. As you can see, I already got it installed, but the important part is these two lines at the bottom. We can copy them and insert them into the CMake lists file to integrate the library into our project. We just have to replace the names appropriately and delete the mylib, because this is just an example. We don't have a library called mylib. And in addition to those lines, we also have to insert this line to choose the Python version we want to use. But that's all. That's the main configuration for this library, and now we can test if everything works by just including the header of the library. As you can see, the program compiles and runs. So the library is working correctly, but there's a lot of warnings, and that's because of the static analysis I enabled in the CMake lists file, and I want to get rid of those warnings. That's why I paste in those lines. The first part of these lines: disable all code analysis, then I include the header I want to have, and then I enable the code analysis again. That makes the warnings disappear. It is a bit ugly, but it works in the end. The next goal is to execute Python code. First I will create a namespace alias, so we have to type a little bit less. And then we have to create an instance of the so-called scoped interpreter class, which only serves as a RAII wrapper around the Python interpreter. And then we can just call the execute or exec command with some Python code in it. As you can see, there's a problem. We are missing the appropriate DLL file. Where to get it? Well, you can download it from the Python website in the embeddable zip file. You can just extract it to the folder where the executable file lies, and then the program should work. As you can see, we are executing Python code inside C++. Now to take it one step further, we want to write our own Python script and then call a function from the Python script from within C++. So I create a new folder called scripts inside the binaries folder, and within this folder I will create a file called __init__.py, which marks this folder as a module. Then I will create another file called example.py, and write a simple function inside it. We want to now call this function from within C++. For this, we first get a handle to the module by importing it, and then we get a handle to the function by searching for it by name. And then we can just invoke that function. And as you can see, we just invoked the Python function from within C++. The next thing I want to cover is error handling. Imagine I would try to invoke a function that's not really in the script, like in this case. What does happen? There's an exception thrown, and the exception has the type error already set. And all errors on the Python side will throw an exception of this type. So we can just wrap our Python calling code in a try-catch block and catch those errors to get a readable error message instead of a crash. So we can see the problem was that some function was not found in the module, and that's the error message. Now we will undo the change, and the program is working again. The next thing I want to cover is handling arguments. So I'm writing a Python function that takes 2 arguments and returns the sum of the arguments. We want to call this function from within C++, so we just search for this function and get a handle to it, and then we can just pass 2 values just like a normal function call. But getting the return value is a little bit more difficult. We have to use the cast helper function and tell it the type of the return value we expect. And then we can just work with this return value like a normal variable in C++. There it is. Now we want to do the same thing in reverse. We want to call a C++ function from within Python. So I write this square function, and we have to expose this function to Python. For this, there's this pybind macro. We define an own module for Python. The module's name is cppmath, and the variable m is used for choosing what to expose to Python. For this, we use this helper function. We give the name and just a function pointer, and the rest is already done automatically by the library. So inside of Python, we can now use this module and use the sqr function from it. To do this, we first have to import the module called cppmath, and then we can use this function from within this module. So cppmath.sqrn. And we just wrote a function that's calling C++, and now we can use C++ to call that function. So both languages can call into each other. As you can see, it works. I will now add a bit more of text output so it's even more clear which language does what. Now I want to define a class inside C++ and also use it inside Python. So I write this little class that represents a rectangle, and then we also expose it inside the module we already created. For this, there's this helper template called class underscore, because class is a reserved keyword in C++, and all the definitions following this helper template are included in this class. For exposing the constructor, there's also this helper method called init. You have to give it the argument list. The rest is straightforward like before. Now switching over to Python, we can just use this class as if it was defined within Python. We can also call methods on instances of it. We can now call the function we've just written inside Python from within C++. We can then invoke the function and pass an argument of type rect and get a float value back. As you can see, it calculates the area of the rectangle. There's one last thing I want to cover, and that is call by reference. For this, I expand the functionality of the rectangle class and provide it with some getters and setters, and also expose them to the module. Now we want to take a reference to a rectangle and just change the rectangle within Python. The problem with this is that if we're now invoking the function and passing an instance of the rectangle class, we are passing the argument by value. That means Python is not able to change the value because it receives a copy. So you can see the area of the rectangle hasn't changed. That's because Python receives a copy and not a reference to the rectangle class. To overcome this problem, we can make a call by pointer, and I'm using the helper function cast just to make it explicit, but it's not really needed. I can just put the pointer in. So this was just a quick overview over what is possible, and you should really check out the documentation of PyBind 11 for more information on that. I hope this video was helpful, thanks for watching and goodbye.